Guys, Mr. Burns here with your video for lesson 6.2T, nets and surface area. The world is made up of many three-dimensional objects. From the blocks children play with to the Great Pyramids of Egypt, solids are all around you. A solid is a three-dimensional figure that encloses a part of space. In this lesson, you guys will learn about 5 different types of solids. Many solids are made up of flat surfaces called faces. Each face is a circle or a polygon, which is a closed figure made up of 3 or more line segments. Solids may have 1 or 2 bases, often located at the top or the bottom of the solid. Okay, the 5 solids that you guys are going to be dealing with are prisms. Okay, and prisms are solids that are formed by 2 congruent parallel bases and rectangular sides. A pyramid, okay, is a solid with a polygonal base and triangular sides that meet at a vertex, sometimes called an apex. A cylinder is a solid formed by 2 congruent and parallel circular bases. A cone is a solid formed by 1 circular base and a curved surface which connects the base with the vertex or the apex. And a sphere is a solid formed by a set of points in space that are the same distance from a center point. Think of like a basketball, okay, or a baseball. A cone, think of an ice cream cone, or a hat, okay, a type of cone hat that you would wear. A cylinder, think of a soda pop can. Pyramids, again, think of the pyramids of Giza. And for a prism, think of a box of some sort, okay. Anyway, so today we're going to talk about nets. A net is a 2-dimensional pattern that can be folded to form a 3-dimensional figure. Okay, so an example of a net would be like if you were to take a box and cut it at its edges, okay, and unfold your box, that would create a net. Prisms and pyramids are named using the name of the base, okay, to form the prism or pyramid. For example, a prism whose base is a triangle would be a triangular prism, and a pyramid whose base is a rectangular pyramid. And you'll see all this at play once we get into the lesson here. The surface area of a 3-dimensional figure is the sum of all the surface areas. So the surface area is on the outside of your shape, not on the inside. That's volume. This includes the area of the bases and the sides, and you can calculate the surface area of a figure by drawing its net, finding the area of each shape in the net, and adding the areas together. So there's 4 steps you guys need to follow to find the surface area of a solid. 1, draw the net of the solid. 2, record the measurements on the net. 3, find the area of each part of the net. And 4, find the sum of all the areas and label your answer. All right, let's jump right into this. Okay, so for number 1, it says, A, name the solid. So it looks like a box, right? Anything that looks like a box is some sort of a prism. So in this case, let's look at the bottom part of this box. I'm going to circle it in green, or circle it in green, color it in green. So that's the bottom of the box. Okay, what shape is that? It's rectangular. And if you look at all of the sides of the box, you'll notice they are all rectangles. So this would be a rectangular prism. Now it says draw a net for the solid. So when you draw the net, okay, take your time, do it and do it well. Okay, but I'm not looking for perfection, I'm looking for excellence. All right, so here we go. The bottom of the net is a rectangle, so draw yourself a rectangle. The back of my prism here is also a rectangle, but it looks like it's a little bit smaller than the base. So something like that. Now you can sit there and draw the top. So this is the back side. I'll put BK for back. And then T for the top, okay. It looks, so the top side is going to be the exact same as the bottom side. So whatever your bottom side looks like, okay, just recreate it as your top side. Okay, something like that. And let's go ahead and put B for bottom. And I'll put BK for the back. I'll put T for the top. Now if you look at the front, which is this right here, the front is the exact same as the back. So I'm going to go ahead and draw the front. and put an F. Okay, so it's the front of my box. Now, if you look at it, you've got your two sides. So that's we'll just call that the left-hand side. And we'll call this back one here the right-hand side. So we'll draw the left-hand side, a little small rectangle there. And we can go ahead and draw the right-hand side of the box just like that. Okay, and the right-hand side is the exact same as the back side. Or I'm sorry, the right-hand side is the same as the left-hand side. So on a prism, on a rectangular prism, there are 6 faces. Okay, and do I have 6 faces? Yes, I've got the front, the bottom, the back, the top. I've got the left-hand side, okay, and I have the right-hand side. And there we go. Number 2. Okay, here we are on number 2. Now, number 2, what kind of a shape is this? Well, if you look at the two parallel congruent bases of this, you'll notice that they are triangular. Well, Mr. Burns, wouldn't this be a pyramid? No, this wouldn't be a pyramid. 1, because all of the other sides are rectangular, and 2, it doesn't meet at a singular point. Okay, so those are the two parallel and congruent bases. And what shape are they? They are triangular. They are triangles. Okay, so let's go ahead and say triangles. And then go ahead and name, and then it says name the prism. Well, if the bases are triangles, it would be a triangular prism. Okay, why is it a prism? Because all of the other sides, I'll put those in blue, are rectangular. Okay, and then it says draw a net for the solid. So let me go ahead and erase all that so I can explain to you the net while I draw it. So on the net, the first thing I like to do is I like to draw myself the base, or not the base, but the bottom of this shape, which is a rectangle. Okay, just think about unfolding your box. So I unfolded the bottom. I'll put B for bottom. And then I'm going to go ahead and do the back part of this prism. Okay, and it's rectangular, so I'm going to go and draw myself another rectangular. And label it BK for back. Okay, and then I'm going to go ahead and put the top of the shape, okay, as it's drawn, okay, in the front. Now the top may not necessarily be the same as the bottom, but it looks pretty close. So I'm going to go and draw myself another rectangle that looks somewhat congruent to the bottom, and I'll call that T for top. And then you've got your left-hand side, and then you've got your right-hand side, that they are triangular. Okay, so you notice that they are triangular. So all you got to do is draw yourself 2 triangles that are attached to the bottom, like something like that. And they should be fairly congruent, right? And there you go. There is your triangular prism. Looks kind of like a rocket. I'm going to draw a rocket. Flames coming out the back. Okay, and then you got your cockpit up here with your pilot. Could be a man, could be a woman, I don't know. Okay, flying their jet fighter or whatever, plane, rocket ship, something. I don't know, just trying to have fun. Okay, number 3. On number 3, it says name the solid. Look at the base. What shape is the base? The bottom of the base is a rectangle or a square. We don't know if it's a square, so we'll call it a rectangle. So this would be a rectangular. So the first word, if you haven't figured it out by now, always names the base or the bases. Okay, so this would be a rectangular what? If you look at all the other sides, all the other 4 sides, you'll notice they are triangles. So this would be a rectangular pyramid. And then it says draw a net for the solid. Drawing a net for the solid is pretty easy. All you have to do is draw yourself a rectangular pyramid. And then go ahead and draw yourself triangles for the sides. And in a rectangular pyramid, you will have a total of 5 sides. So there you go. Sound good? All right, let's go ahead and jump to the back side. Okay, so here we are with number 4. On number 4, it says follow the steps to find the surface area of the rectangular prism. So here you have your rectangular prism. All right, and you've got the measurements. The measurement that's right here, the 5, I'm going to call that the width. 20, how far back it is, I'm going to call that the length. And how tall it is, that's going to be the height. So you've got your width, your length, and your height. Now for part A, it says draw the net, or draw a net of the figure, and then measure all, put all the measurements on the figure. Part B says find the area of each figure in the net, and then write the areas inside the corresponding figures. And then C, it says find the total surface area. I'm going to do all of my work on a separate sheet of paper, and I would suggest that you do the same. Okay, so for number 4, I would suggest that you do your work on a separate sheet of paper. And you can refer back to the video or watch the video, and as you watch the video, refer back to your homework assignment. Okay, here we go with number 4 on a separate sheet of paper. Okay guys, Mr. Burns here with number 4, and what it is I recreated the rectangular prism on this page, and I also wrote in the measurements. What I'm going to do is I'm going to divide this up into its 6 different faces. Okay, the first thing I'm going to do is I'm going to go ahead and draw in the bottom face. And by doing this and breaking it up into its individual parts, it'll make calculating the total surface area a lot easier. So let's go and draw the bottom face. The bottom face is a rectangle, so let's go and draw in our rectangle. All right. Now, the width of our rectangle is 5 inches, and the length of our rectangle is 20 inches. Okay, to find the area of that rectangle, it's going to be length times the width, so it's going to be 5 times 20, which is equal to 100. So the area of the bottom face is 100 inches squared. All right, and that's a 2, not a 7. And let's go ahead and do the bottom, not the bottom, the bottom. On the bottom, yes, the bottom. All right, anyway, enough of the funny noises. Let's go ahead and draw the back. Okay, so I'm going to go ahead and draw the back face. Back face is also a rectangle, so let's go ahead and draw ourselves in a rectangle. Just like that. Now the width of the back face, okay, is going to be 3 inches, and the length is going to be 20 inches. All right, so to find its area, we're going to take the length, which is 3, times the width, which is 20, or vice versa, and 3 times 20 is 60. Okay, so the area of the back face is going to be 60 inches squared. Okay, so there's the bottom and the back. See if I can shrink this down. Oh, perfect. Set that off to the side. Now, let's go ahead and do the top and the bottom. Now, the top is parallel to the bottom, which means what? They're exactly the same shape and exactly the same size. So if you know what the bottom area is in a rectangular prism, the top area is also going to be the same. So the top area is going to be 100 inches squared. Now that's the same thing with the back and the front. So since the back and the front of a rectangular prism are parallel and congruent, their areas are going to be the same as well. So if the back area is 60 inches squared, then the front area is also 60 inches squared. Make sense? All right, so far we have 4 of the faces. We need 2 more. We need the left-hand face and the right-hand face. So I'm going to go and label the left-hand face. Okay, so the left face is a small rectangle, so let's go and draw that in and write in its dimensions. The short side is 3 inches, and the long side is 5 inches. Okay, and the formula for the area of that rectangle is length times width, so it's 3 times 5, and 3 times 5 is 15 inches squared. And just like before, using the same logic, the left-hand side and the right-hand side of this rectangular prism are parallel and congruent, which means they have the exact same area. So if the left-hand side's area is 15 inches squared, then the right-hand side's area is also 15 inches squared. All right? So to find the total surface area, for part C on number 4, all we have to do is add up the 6 areas that we've got. So let's go ahead and do that. So we're going to take the bottom, add the top, add the back, add the front, add the left-hand side, and add the right-hand side. And when you add up all those numbers together, you should get a grand total of 350 inches squared for the total surface area of this rectangular prism. All right, let's jump on to number 5. So before I forget, for number 4, the total surface area that we found was 350 inches squared. Okay, on number 5. On number 5, it says follow the steps to find the surface area of the pyramid. Part A. So on this one, okay, let's see. We've got the base of our pyramid, which is 10 meters by 10 meters. So if it's 10 meters by 10 meters, that's a square. And it's a pyramid because all the other 4 sides of this square pyramid are triangular. And the height of our one of our triangular faces is 8 meters. So the height of one of the faces of our square pyramid, okay, is 8 meters, which is going to be important when we talk about the surface area. Okay, for part A, it says draw a net of the figure and then put all measurements on the figure. So here we go, let's draw our net. So the net is a square. I'm sorry, the net is square. The base of our net is going to be a square. And since this is a pyramid, all the sides are going to be triangular. That's all you got to do. And then it says put all the measurements on the figure. So on our square, all the sides are going to be 10 meters for all of the sides. Okay, and then the height of one of our triangles is going to be 8 meters. All right, and then for part B, it says find the area of each rectangle in your net, and then write the area inside the corresponding rectangle. I'm going to do my work over here off to the left, okay, to find the area of that rectangle. So the formula for the area of a rectangle is area equals the length times the width. The length is 10 times the width, which is 10, and 10 times 10 is 100, and it's meters squared. And that is the area for the base. All right. Now we're going to find the area of each of the triangular sides. So the formula for the area of a triangle, I'm going to put that on blue, and I'm going to put the area triangles, I'm going to put it over here. Okay. So the formula for the area of a triangle is area equals 1/2 the base times the height. And that's only for one of the triangles. Now keep in mind we have 4 triangles, okay, that we'll have to find the total surface area for here in just a moment. But let's stick with one for right now. So we've got 1/2 is 1/2 times the base, which is 10, times the height, which is 8. So 1/2 of 10 is 5, and 5 times 8 is 40. So that's the area of one of the triangular faces. But there are 4 of them, so we're going to take 40 and multiply it by 4 because we have 4 faces. And 40 times 4 is 160, and it's meters squared. All right. Then for part C, we got to find the total surface area. So the area for the square base is 100, plus the area of the 4 triangular faces. The total area is 160, and 100 plus 160 is 260, and it is meters squared. Okay, so that's the total surface area for this square pyramid. All right, number 6. Okay, on number 6, it says Natalie wants to determine the surface area for a cube that is 2 centimeters on each side. So it says draw a net for Natalie's cube. So on a cube, there's think of like a number cube that you would use for a board game of some sort, and there are 6 sides to a cube. So all you have to do is draw 6 squares that are interconnected at some point. So here we go. Let's go ahead and draw the bottom. Let's go ahead and draw the back. Let's go ahead and draw the top. And let's go ahead and draw the front. And then for the left-hand side, let's go ahead and draw it right here. And then for the right-hand side, we can draw it like that. Okay, so there you got it. That's your net. Now it says find the surface area of the cube. Well, the formula for the area of one square is area equals the length times the width. Or you can go area equals, and that's an R, not a V. Or area is equal to the side squared, since this is a cube and all of the sides are a square. So let's go ahead and write this down. So area equals the length times the width. So it's going to be 2 times 2. And 2 times 2 is 4. But since we have 6, okay, since we have 6 square faces, we're going to take the number 4 and multiply it by 6. And that's going to give us the total surface area. So 4 times 6 is 24. And it says, since it's the surface area, its unit of measurement is going to be centimeters squared. And there you have it. That's it. Let me rewrite this so it's a little bit neater, a little bit nicer. So it's 24 centimeters squared. And then for part 6 it says, for part C on number 6 it says, how could you solve this problem without using a net? Well, you could develop a formula, right? So what I'm going to ask you guys to do, okay, what I'm going to challenge you guys to do is come up with a formula that will help you to calculate the surface area of a cube without using a net. All right? Other than that, let's go ahead and get out a piece of paper, pencil, and a calculator, and let's get ready to write down our assignment. Nice job, you guys.